welcome to the last session of the Innovation Week 2025. I'm Carole Tonello. I'm VP, Vice President of Business Development at Hiperbaric. And today my talk will be about sustainability of HPP and how HPP can improve the sustainability of food and beverages. So I will start with the sustainability of the technology, the equipment, and the packaging in the first part of this presentation, and then I will focus a little bit more on how the technology can improve food sustainability. In Hiperbaric, we design our equipment in order to be the most sustainable as possible. Of course, any processing has an impact, but we try to minimize it. So we have an eco design of the machine using materials that are not contaminating. Trying to have a low footprint to minimize the use of the natural resources, which are the main one we use with the technology are water and electricity. So concerning water, this technology pressurizes the products through a fluid, which is the water, and 85% of the water we use is reused by the machine. The 15% which is not recycled is the one exiting from the discharge valve at the end of the cycle. And it gets hotter going through the pipes during the depressurization. And this one is clean, except, of course, if you have a package that would break and contaminate this water. In this case, we have filters. But this 15% water, a little bit warm, I would say, can be used, for example, for cleaning if you want to recover it. The technology HPP has an advantage is that we do not generate polluted wastewater because we use clean water. Each time we increase the pressure, we do the cycle, we HPP the product, but we HPP also the water, of course, because the water is at 6,000 bars, so we kill microorganisms inside. So we can use for hours and days the same water. When scientific studies compare the water efficiency of HPP, for example, with thermal processing. So in this case, you have the example on the slide of processing a fish soup for 5 minutes at 2 cycles of a little bit more than 5,000 bar, 5,200. And you can see that the processing water use for the same comparing for this product is much lower for HPP than for the thermal processing. So we can save in volume. We can save a lot of water. So we are more sustainable. The same product was evaluated concerning energy efficiency, and what we could see, you could see with the bar, that the energy of processing itself, it's more or less similar, a little bit less, 3% less than the energy we would need for the equivalent thermal treatment to achieve the same shelf life or pathogen inactivation. But we save a lot of energy because we don't have to cool down the products. This is HPP, the non-thermal technology, and so we do not heat up the products, so we don't have to cool down. And the good points of the technology is that we use only electricity. In general, the thermal treatment, they use vapor for heat exchangers. And so they use, in general, natural gas or energy that are not renewable. More and more in many countries, we have electricity coming from renewable, from wind, from solar, and so the impact on the earth or the sustainability is improved. What we can see in this life cycle assessment, in this case, this is the orange juice. When they compare the thermal processing with it exchanger for orange juice, the HPP on average is less environmental impactful than the thermal pasteurization. And the explanation is that we are fully electric, so it's much easier to have clean energy, and as we could see with the fish in general, the consumption is quite similar, energy consumption quite similar to the thermal processing. Using electricity, this is a huge benefit. And when we are a little bit more when the technology, when HPP have a result which is a little bit worse than the heat treatment. This is ionizing radiation, freshwater ecotoxicity, marine ecotoxicity, and a little bit, in this case, a little bit more of water consumption. Well, the last one not, but the two other are related to the use of the electricity, if you compare with some other. So I would say that in average, we are much better than thermal treatment with HPP. Not cooling down and using only electricity. Concerning sustainability, also the major point to take care too is the generation of waste. So three types are to be taken in account: liquid effluent, food waste, and packaging. Concerning liquid effluent, we do not contaminate the water, so we need less, as it's an impact, when it's an impact, as it is an impact process. We do not contaminate with the product the machine, so we need less aggressive equipment for cleaning. We don't have to sterilize the packaging because we process in pack, so the packaging is pasteurized or the microorganisms in the packaging are inactivated during the cycle, with at the same time that we inactivate microorganisms in the food or the beverage. And so in general, we reduce the chemical agent we have to use for this process if we compare with thermal pasteurization. Concerning food waste, we have big benefits. We extend shelf life. So less food will be thrown, less food is spoil before it's consumed. The extension of shelf life allows to have a better organization of production. If you increase the shelf life, you don't have to do all the products every day. A lot of products that stay in the tanks, so you can make big runs. You clean less because the run of production are longer. So this is also one of the benefits of the shelf life extension. There is a part of the shelf life that allows a better management from the food or the beverage producer. And we inactivate pathogens, so we can avoid with HPP recalls. The last, just two examples. For cook ham, life cycle assessment was performed in a study something like 10 years ago. And we have to take in account that in this case, HPP does not replace the thermal processing. the way of producing the ham is exactly the same. So this is cooked, this is packed, and then it's sliced, and the sliced ham in this case is processed by HPP. So it's an additional process. But when you take in account all the life cycle assessment for the cook ham, so starting from the pig, I would say, and up to the end of the consumption of the product of the cook ham, HPP has an impact equal or less than 0.1%. So it's very small part. Of course, we have to work on the technology on every point, on every step to reduce or to increase the sustainability and to reduce the environmental impact. But really, we have to think that HPP, even if it's an additional process to the regular process of the product, in the case of ready meals, sliced meats, the impact is really limited. And this study was interesting because they show that it's balanced by the food safety. If the product is safer because we have no presence of pathogen, we eliminate the risk of having people to cause problems on health. So people at the hospital and all the consequences, which has an impact on the environmental results, if I can say, analysis. And they say that the exposure to pathogen presents a more relevant impact for human health than the consequences associated with ozone layer depletion. So we also have to take care of providing safe product, of course, for the health of the consumer, but also because the illness has an impact on or decrease the sustainability. I have another example. In this case, this is life cycle assessments of oranges, and this study, which is from 22, if I remember well, 2020, they've compared HPP, which is in blue, and in the retort process, this is gray, and the orange bar is indirect or heat exchanger pasteurization. As you can see, reaching 100%, we have the retort process, so the gray bars. Having a low low impact, we have lower impact, we have the indirect pasteurization, but the lowest is, in this case, also HPP in the different factor that we can take in consideration. So globally, HPP has a lower environmental impact. Last point we have concerning waste. This is the packaging. So we need for the process a flexible packaging resistant to water. So this is polymeric product, and in general, this is plastic. What we have to understand is that with the HPP, we can replace, for example, or we can be much better in shelf life and, of course, in inactivated pathogen if we compare with modified atmosphere packaging. Because with the gas of modified atmosphere packaging, we can control some spoilage microorganisms. We cannot inactivate pathogen in general. On the contrary, with HPP, we are efficient. We are killing pathogens and spoilage microorganisms. And the interest is that if we change vacuum pack HPP for, if we switch from MAP to HPP and vacuum pack, we have a benefit of concerning the environmental impact. Why? Because mainly we use no gas, of course, because it's vacuum, and we reduce the quantity of plastic for each kilo of products we process. So you can see that in the case this study was done in 2022, 2020, sorry, for Parma ham, and clearly this is the LCA is much better. The results are much better with HPP than with MAP. Talking about sustainable materials, if we don't want to use plastic directly coming from petrol, we can use sustainable materials. There are options like bioplastic, PLA, for example, polylactic acid. We have also the possibility to use recycled PET, for example, and there are some other biodegradable solutions that are developed so the microorganisms are able to digest the PET. So we can increase also the sustainability and replace the classical plastic packaging. Another possibility to increase the sustainability with HPP is switching from large packages, so from small to large. We have developed, in collaboration with the company Container, a keg, which is a flexible keg that can resist to HPP and can be used, for example, in bars or restaurants when you have to deliver juice or any other type of beverages to the glass. So if you don't use the bottles and you use a keg of 20 liter, comparing in this case, we save 97% of plastic. So this is a sustainable option when you need large volume. We have develop another technology, which is the bulk technology. In this case, the beverage, the juice is processed in a big pouch that can be reused many cycles, more than 100 cycles. So runs from up to 2 to 3 days, for example. And the liquid, the beverage enter from a tank and exit from a tank, and then we need extended shelf life or aseptic bottling. This has some benefit. The productivity is increased because we fill the vessel with a lot of juice each cycle, so we can reach 90% filling ratio. And so this minimizes energy consumption because the energy required to increase the pressure is for, I would say, more liters, a larger volume of juice. So we minimize energy consumption with this technology in bulk. And also we give an option for packaging because as the packaging is after HPP, we can use carton, we can use glass, we can use more sustainable options than the classical one that can be used with the impact technology. So the sustainability of the products itself, or how HPP can improve the sustainability of food and beverages themselves. Well, what we know is that the style of life we have in many countries all over the world is that we eat more and more ready-to-eat, convenient products. And so those products need to have shelf life, need to be pre-prepared and ready, I would say, ready to eat, so be safe. And so they are, in general, they are packaged and they can be, I would say, in general, less sustainable than the less processed products. And so the problem of the food waste is, I would say, very large, because the FAO estimates that about 30% of all the food produced all over the world is lost or wasted. In some countries, the problem is the processing, when the food are really not really processed. A lot of grains and can be lost because we cannot preserve them. In more developed countries, more advanced countries, we have more processing, but we have more packaging, more waste, because the shelf life of the ready to eat products can be too small, and it's thrown. So it's a billion-ton problem today, and 28% of the landfill is lost because it's used for food that will finish in the bin. And this is 30% of the global energy. So this is really huge. By category, which type of products are more thrown or more waste? First, we have meat, poultry, fresh. We have vegetable, dairy products, and fruit. So for this category, those four first category on this graph, what HPP can be used to stabilize, to preserve, to increase the shelf life. So this is HPP is a technology that can really help. Extended shelf life. Well, we can stabilize for weeks total areots, lactic acid bacteria, so stop the spoilage and increase the shelf life from, I would say, 4 times to 30 times, depending the products. So if we have, if the consumer has a longer time to eat the product, less product finish in the bin. So we reduce food waste. In the case of pathogen, as you can see here, Listeria, E. coli, Salmonella, we can inactivate more than 5 logs, for example, in avocado or guacamole. An interesting survey has been done by FDA between 2017 and 2019, and they analyze more than 300 samples of guacamole, non-processed or HPP. And what they could see was that 2.5% of the non-processed were contaminated by Listeria monocytogenes and 0.6 by Salmonella. The HPP ones, they were without contamination. So really the technology is efficient. Another way HPP can help to improve sustainability is upcycling. There is a lot of ugly fruits of vegetable, and that can be reused, that can be cold processed, and you can go from, I would say, a product that could be destroyed, you go to a high value product like cold pressed juices. And we have a nice example with one of our customers in Canada, which is Loop Mission, and they use ugly material, and they say that, for example, that per juice of bottle they can rescue 1.4 kilos of fruit and veggie that it's not possible to sell directly, but can be perfectly used for a nice juice. How the technology can improve the sustainability, also by providing the consumer clean label products. We know that the chemical preservative have an impact on health. This is clear, and so going to a technology which is a physical preservation like HPP is beneficial if you compare with the chemical preservation with the chemical preservative, and especially this is interesting for the vegetable products. We can keep really the freshness, the nice flavor, and offer the possibility of preservative-free products. For plant-based solution, as I said, which is roughly 2/3 of the products that are processed in HPP machine all over the world, the technology allows to increase the consumption of those products, which can be, of course, with the clean label, also organic products if required. Because we maintain the freshness, but we increase the shelf life and we reduce pathogen contamination. This allows to some companies to develop very innovative products, like the plant-based meat made from grain, like ledges, hummus, for example, and I will not talk about guacamole because it's a really, I would say, classical product. The technology is very innovative, it's sustainable, and it allows to bring to the market sustainable food and beverages. This is HPP is a technology for any type of company, from the smallest, the startups, to the biggest one. We are collaborating with our customer who are from the universities, R&D center. They offer testing. This is what we call the academia network. If you want to have more information, you can see it on our website. And for sure, there is not far from you one member of the academy network that could help you. And in any case, if it's not possible, you can come to one of our pilot plants. We have one in Burgos, Spain, one in Miami, United States, and one in Shanghai in China, to develop innovative application, like, for example, seaweeds or cultivated meat or insect-based food. We would be really we would really enjoy to receive you and to help you to develop those beautiful new products. And last but not least, if you want to know about another technology, which is hypersure thermal processing, HPTP, for shelf-stable products or chill-stable products, depending the temperature we use, I recommend you to watch the session of this Innovation Week, the Innovation Week 2025. HPTP explain a smarter alternative to traditional thermal processing. And with this, I think we can conclude that the HPP replies to the consumer and the industry aspiration in the future: low carbon footprint, sustainable packaging option, healthier food and beverages products. We have solution for full automation with the technology, and it can bring very innovative products, safe and fresh. With this, I thank you very much for your attention, and I hope you have enjoyed this HPP Innovation Week 2005. Goodbye.